Remember, before I start, this is 0 pi. And then when I trace all the way around and go back to where I started, it's 2 pi. So from 0 to 2 pi is before it starts over. That's a period. And we'll talk more about a period in a moment. All right, so we're going to break up the sine values from the cosine values. So those are different graphs, but they have the same input. They're both going to share the same input. The input, the x values, are the radians of a period. And a period is just a fancy word before it starts over again, before the wave starts over again. All right, so for the sine value, let's go ahead and talk about the highest the sine value ever gets and the lowest the sine value ever gets. The highest the sine value ever gets out of all these numbers, the highest y coordinate is 1. So we're going to put the highest value up here, the highest this curve is ever going to reach for sine is 1. The lowest value for sine is -1. So let's put -1 down here. Notice that I am maximizing the space of the graph printed on the paper. Now, since that's the highest and the lowest forever, I'm just going to go ahead and block out the ceiling and the floor. And I'm not drawing anything that's not required on a quiz or a test. All right, that's the highest it's going to get. That's the lowest it's going to get. This is 0. Remember, these are output values on the y-axis. These are sine values. All right, now again, if I trace this all the way around, I'd start at 0, I'd end at 2 pi. That goes on the x-axis. So let's write 0 pi right here. And as far right as you can, let's write 2 pi. And let's just plot the outputs. Now look, 4 quadrants in a coordinate grid, 4 parts of a unit circle. We have to divvy this up into 4 parts. So the parts are always going to be, I'm going to kind of estimate my tick marks. I'm going to try to space them as evenly as I can. Remember, this is the beginning. The top, y'all remember the radians of the top? What's the radians up there? There you go. Good job. That's going to be pi over 2. What's the left side? Just pi, yes. And the bottom is, there we go. It's coming back to us. And remember, it would take us back to the beginning, which is 2 pi. Y'all, we're just graphing the sine values. What's the sine value at 0 pi? It's 0. So the graph's going to start right here. What's the sine value at the top? It's a 1. So it hits its max up here. What is the sine value on the left? It's 0 again. And then at the bottom is when it reaches its lowest point. That's -1. And then, remember, at the end of the circle, it just starts all over again. So I'm going to draw the shape. So that's what a sine curve looks like. But y'all, look, kind of extend this and show that it does continue. Look at my little tail at 2 pi. You got to draw that little piece. Same with 0 pi. It does repeat. So that's it. That's the sine curve. And it is a function. It would pass the vertical line test. Let's do cosine. All right, so kind of a lot of similarities. I mean, we do start at 0 pi. We do stop at 2 pi. The highest value is 1 and the lowest value is -1, so still kind of the same thing. You do. I don't draw anything on here that's not required. All right, we're still going to break this period up into increments according to the unit circle. So remember, the top is pi over 2, the left is pi, and the bottom is 3 pi over 2. But remember, it doesn't start at 0, 0. Where does cosine start at the beginning? It starts at 1. So this graph is going to start up here. There's where it starts, and then it goes to 0. And then remember, on the left side is where it's its lowest. Then it goes back to 0, and then it goes back to where it started. So that's how we get our little cosine curve. And again, kind of draw those tails because it does repeat. It's a wave. And that's it. One important thing that we need to remember moving forward is sine always starts at 0 pi 0. Always, 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 no matter what. Cosine never starts at 0, 0. It starts at 0, 1, and that's going to change. This is never going to change, but that is. Why is that going to change for cosine? Because stretches and shrinks are coming back. Look, let's go to the bottom of the page. Oh my gosh, what is a sine? What is a cosine? Y'all already know that. The a value is the same that it's always been. It's a stretch or a shrink. But we're dealing with trig functions, so the a is actually an amplitude. How much amplified is it from the origin? Remember that you can have an a value of a stretch. Of course, if it's greater than 1, compressions if it's less than 1, if it's a fraction. If it's negative, y'all, it's not an amplitude. If it's negative, it just tells me it's a vertical reflection. And I'm just going to use VR for negative a values, vertical reflection. And B values, some of you guys already know too, B values are not vertical stuff, it's horizontal stuff. So if I have a B value that's a horizontal compression, it's going to make those waves really skinny and close together. If I have a stretch, it's going to take a long time for an S to happen. So, and guys, remember it's in parentheses, so it's always weird. That's going to affect how long it takes to start over. And guys, I know there's a division sign right there, but we're going to always just multiply by the reciprocal of b to get how long it takes to make that shape. So remember, a period is the width it takes to make the shape. Or how long it takes on the x-axis for it to start over. Speaking of the x-axis, remember, if you look at your graphs up here, there's 4 pieces that happen. It starts, then it goes up, and if it goes up, it goes down. If it goes down, it either goes up or it goes down again. This continues to go down. So we always break our period into 4 increments because of the 4 parts of the x-axis. So, again, y'all, I know it's being divided by 4, but it's going to be so much easier mentally if we just multiply by 1/4. And these increments are just tick marks on the x-axis. That's all that is. Okay. Let's turn the page and start graphing this stuff with more numbers on it. All right. At the top of the paper, guys, I'm going to write steps for you that are always the same. You're always going to use these steps. All right. Step 1 is to find where it starts. Step 2 is to draw the a value. Remember, it's a stretch or a shrink. It's called amplitude. You do need to know it's called amplitude. Number 3, we're going to find the period. Number 4, we're going to find the increments. I'm just going to abbreviate. Remember, the increments are what we put on the x-axis. And step 5 is just to graph it. And guys, you should remember, I wish I would have told the other classes this, but you do need to remember a sine curve looks like an S, a sideways S. And a cosine curve looks like a valley. Do need to know those shapes for sure. All right, let's go ahead and get started on some stretches and shrinks here. So number one, I'm just going to follow my own steps. 1, 2, 3, 4. I don't need to draw a fifth one for a graph. All right, number one is to find where the graph starts. So easy for sine. Sine always starts at 0, 0, always. Number two is to draw the A value. The A value is the amplitude. The amplitude is right after the equal sign. The amplitude is 3. So it is going to be an amplitude of 3 places above the middle, which is at 0, and 3 places below the middle, which is -3. Your A value is always positive. It's a distance. Number 3 is to find the period. The period is going to be 2 pi unless you have a number in the parentheses, and you do. So it's not 2 pi. What is the period going to be? It's going to be 2 pi times the reciprocal of what's in there. So let's write 1/4. All right, so 2 pi times 1/4 is 2 pi over 4, which of course is pi over 2. So the parent function, the whole S, took 2 pi radians to happen, but not this. This is just going to be pi over 2. But we need to space that equally. Remember, it always starts at 0. This number is always at the end. This is always here. We're just going to cut it into fourths equally, spatially, and algebraically. So try to mark your increments as equal as you can, and then let's go ahead and divide those by 4. So pi over 2 times 1/4 is going to be pi over 8. That's our increments. That's our tick marks, y'all. It's just pi over 8. So this is 1 pi over 8. This is 2 pi over 8, 3 pi over 8, and that's 4 pi over 8, which is indeed pi over 2. This is making me crazy, but I'm just going to leave it since it's our first example. On a test or a quiz, I would have to write that as pi over 4, so everything must be simplified. But it's okay for now. All right, let's draw our S-curve. So, it's a sine, it's a S, but where does it start? Oh, I know, that was step 1. It starts with the origin. So we're going to draw a dot at the origin, and then remember your shape. After that, it reaches the top, then it goes back to the middle, then it goes to the bottom, then it goes back to the middle where it started. So my sine curve looks like this. Now look, when you graph these, they are all going to look exactly the same. But remember, if y'all plugged these in on Desmos or on your Inspire, they'd all look different because of these values. They just look the same because we're spacing them the same. We're using the same scale on each one. All right, let's do cosine. Let me write my steps. 1, 2, 3, 4. 1, 2. All right, where does cosine start? Normally, don't write it. Normally, it starts at 0, 1. But cosine, when you have transformations, the first number is always 0. But the second number is the A value. So this isn't going to start at 0, 1. It's going to start at 0, 5. Because 5 is the A value. And remember, A stands for amplitude. The highest it gets is 5 places above the middle. The lowest it ever gets is 5 places below the middle. Let's go ahead and extend those out. right, remember next is the period. How many radians is it going to take to make this curve, this little valley looking thing? So this is going to be 2 pi times the reciprocal of b, so let's write 1/2. So this is going to be short. That's going to be 2 pi over 2, which is just pi. It's going to take pi radians for it to make a shape. So I know this is going to end in just plain pi. It always starts at 0, but I have to figure out what these tick marks are going to be, so I have to divide by 4. So, not divide, let's multiply by 1 for it. Guys, each tick mark is going to be pi over 4 apart. So here's pi over 4. Here's 2 pi over 4, but I'm not making that mistake again. I'm simplifying that. Here's 3 pi over 4. All right, let's draw it. Where does it start? Well, we know because we stated it at the beginning. It's going to start at 0, 5. So remember, cosine starts high. Then it goes through your mid, and then it gets to the bottom of the valley. Then it climbs its way back up. So that's your cosine. Any questions on that? We're almost done. It's almost the same. They're just going to be reflected upside down at the bottom. I know they're going to be reflected upside down because there's a negative first. All right. I'm going to draw my steps here. All right. Number 3. It's a sine function. Oh, so easy. It always starts at 0, 0. The a value, now look, if I ever ask you for the amplitude, even though it's negative, remember amplitude's a distance. So y'all have to write 4. You have to write a positive number. I will ask you that. It has to be a positive number. Just know in your head when you go to graph it, it's going to be upside down, vertically reflected. Let's figure out the period. This has a horizontal stretch, which means it's going to take a long time to make this curve. We're going to have to flip that upside down. We're going to multiply by 4. The whole S has a width of 8 pi radians. So if it starts at 0 pi, over here it ends at 8 pi. But let's break that into fourths. So 8 pi times 1/4. So all of my tick marks are going to be 2 pi. 0, 2, 4, 6, 8. Oops, I forgot to draw my amplitude. I went out of order. I'm sorry. Let me go up 4 to the top. The highest this is ever going to reach is a positive 4. The lowest it's ever going to reach is a negative 4. All right, now we're ready to graph it. Okay, where does it start? We know where it starts. We wrote where it starts. It starts at 0, 0, but it's reflected. So we used to go up, but not now. We're going to go down first. Then we go hit the middle. Then we go up. Then we go back where we started. So there's your sine curve. Reflected. All right, we're almost done. We're just going to create a little mountain curve out of this cosine because it's going to be flipped upside down. Look, your cosine starts at 0 or 0 pi, the negative 1/2. Don't forget, it's always the a value for the y-coordinate. Speaking of the a value, the a is a 1/2, and I'm going to draw that right now because I forgot to go in order last time. All right, there's the midpoint, the highest it's ever going to get and the lowest it's ever going to get. All right, let's talk about the period. Remember, the period is affected by the B value. What's the B value? Yeah, so there's no effect. Y'all, if there's no effect, we're going to block this off just like we would for a unit circle. 0 pi. Remember, it ends at 2 pi. And then just break it. Remember, the radians for the top half is pi over 2. Remember, the left side was pi. And then this 3 pi over 2. But remember, y'all, it's reflected. Where does it start? We wrote where it starts. It starts down here. Then it goes to the middle. Then it finally climbs to the top. Then it climbs back down again. So that's it. That's your curve. One more thing I want to point out, and then I'm going to let you guys work on this. I'm going to give you pictures of curves. And y'all, pictures of curves start getting crazy. Just remember, here's your sideways S. I know that S is not reflected because it goes up on this top part. It goes up first, and then it repeats. It goes up from the middle. From the middle, it goes up. From here, it goes down. After it starts, it goes down. Cosines are a lot easier because cosines are either valleys or they're mountains. That's it.